Unified dynamics.
Hi, my name is Benjamin Mays, theory architect for Unified Dynamics, and this episode we look at the Koide formula.
It relates the mass of the electron, the muon, and the tau particle, and it yields a ratio of almost exactly 2/3. The standard model offers no structural explanation for this specific fraction. Because lepton masses are generated by Euclid couplings to the Higgs field, the model treats the 2/3 ratio as an empirical coincidence or mere numerology. This lack of explanation stems from a core assumption. By relying on a continuous spacetime background, the standard model must treat particle masses as unbound free parameters. They are values to be measured, not limits to be derived. Yet the measured ratio sits at exactly 2/3. The statistical probability of 3 independent mass values aligning to produce a perfect low-integer fraction by pure chance is remarkably low. The cost of assuming a continuous spacetime background is accepting 19 manually tuned free parameters and leaving hierarchies like the lepton masses completely unexplained. The Unified Dynamics framework discards the continuous spacetime background entirely. It replaces it with a pre-metric background-independent structure. This geometric model is the fundamental primitive of Unified Dynamics, the K4 tetrahedral simplex. It consists of exactly 4 vertices, 6 edges, and 4 faces. In this framework, what we measure as particle mass is not the result of a field coupling. Mass is natively generated by topological closure limits operating strictly within this discrete network. By applying these closure limits, we can replace the empirical coincidence of the Koide formula with a rigid, zero-parameter geometric invariant. The 2/3 ratio is a strict mathematical boundary condition dictated by the 3D simplicial substrate. Standard physics observes 3 sets of lepton fields and records their masses. It does not explain why there are exactly 3 generations to begin with. To find the structural origin of the lepton families, we look at the internal symmetry group of the K4 lattice. We isolate the alternating group, A4, and the Klein-4 group, V4. Dividing the alternating group by the Klein-4 group yields a quotient group of Z3. This specific Z3 quotient symmetry mathematically requires exactly 3 distinct cyclic states. These 3 cyclic states across the lattice vertices correspond directly to the electron, the muon, and the tau particle. The existence of exactly 3 lepton families is a forced topological requirement of the A4 over V4 quotient symmetry. For these states to persist as a stable structure, the generations must establish phase coherence within their spatial limit, a concept called mutual structural agreement. This diagram illustrates the phase mismatch constraint required for topological closure, defined by the formula K equals D plus or minus 1 divided by 2. From this mismatch constraint, we extract the maximum agreement threshold for any odd-dimensional space, D. The formula is D minus 1 divided by D. Applying the 3 spatial dimensions of our observable universe into the threshold equation, the result is exactly 2/3. We arrived at this value using 0 free parameters and no fitted couplings. The bare spine of 2/3 is the absolute phase limit of the Z3 character expansion, operating strictly within a 3D discrete substrate. Experimental measurements of the Koide ratio yield 0.66666605, a slight deviation from a perfect 2/3 fraction. This is the universal dressing rule. It separates any observable value into 2 components, the exact bare structural spine and a small native accommodation dressing. The bare ratio of 2/3 represents the idealized saddle point history of the partition function. This table catalogs the active hierarchies. The ZQ term is the microscopic accommodation dressing, derived natively from the partition-weighted average of the substrate to account for the deviation. Because of its foundational position in the Z3 character expansion, the Koide dressing sits at 10 to the minus 5, the smallest magnitude in the entire Unified Dynamics hierarchy. Deriving a geometric constraint that lands exactly on the observed microscopic margin eliminates the need to dismiss the Koide ratio as a numerical coincidence. These terminal logs confirm the formal geometric derivation of the Koide ratio, marking the closure of the particle bridge layer in the unified dynamics program. This derivation joins a specific set of primary combinatorial constants built entirely from the tetrahedral primitive. This table details the exact fractional derivations: the fine structure coupling at 7/960, the heavy lift at 101/6, and the neutral seed threshold at 43/7. A single unified combinatorial grammar generates all 28 of these predictions. The continuous free parameters of the standard model are systematically replaced by the primal topological invariants of the K4 simplex. This entire architectural framework executes with 0 free parameters. As the jagged edges of the K4 network undergo rapid destructive interference, they coarse-grain into what we observe as the smooth, continuous Vierbein tensor. Continuous metric spacetime is a statistical illusion. Reality is governed natively by the discrete capacity limits of unified dynamics.
Don't forget to like, subscribe, and share, and keep questioning reality.